what a quadratic equation is. So I'm dealing with quadratic equations. I'm generally talking about something that has x squared in it, like y equals x squared and some other stuff. The shape is the little kind of U shape that's right there. That's what you're looking at. So if you have a quadratic equation, it should have that U shape. Specifically, when we talk about solutions, we're talking about the idea of, where does it hit the x-axis? When I say solutions here, I mean, okay, if I graph it, where does it hit? Right on the x-axis. So when y is equal to 0. So essentially, anywhere on this line that it hits, those are the solutions. So you can see in this one, it's here and here. So at positive 5, so I could say that x is equal to 5 and x is equal to 9. And the key issue that you're really dealing with here when it talks about the zero product property is the idea that it's only when y is equal to, y is equal to 0, so when you're on the x-axis. We're going to kind of lock that in and see if we can solve for it. That's the goal of the zero product property. In some cases, you get extremely lucky, and they go ahead and factor it out for you. Hopefully, you've done some polynomial factoring where you had to use, I talk about slide and divide, but you may just have x squared minus 14x plus 45 like this one, and you would factor it into x minus 5 and x minus 9. Well, the goal is that if you have it set up that way and it's already factored, and it says equal to 0, the zero product property talks about the idea of, well, let's just set them equal to 0 separately. So x plus 1 equals 0. Well, to solve it, x is equal to negative 1. So that's one of your two solutions. The other one, you do x minus 5 equals 0, and you just add 5. And you'll say x is equal to positive 5. So my answer would be negative 1 and 5. That's the kind of stuff you'll deal with zero product property. Now, the reality is when we're doing this, sometimes the questions look exactly like the ones that when they say, okay, what form do you want them in? So this is referred to as factored form. And these are referred to as solutions. You'll need to know that because, as you can see, the signs are different. Because when you set it equal to 0, you move it to the other side, it changes the sign. So depending on what the question asks you, you need to adjust your answer. It's not a serious change. I mean, it's nothing that you couldn't get your head wrapped around. It's just you need to know that in case you don't know it. So let's do the other one. 7x minus 2 and 5x minus 4. So all we're going to do the zero product property is just set the first one equal to 0. So add 2. Basically, in this case, it was one-step equation, whereas in this one, it's 2 steps. Divide by 7, divide by 7. X is equal to 2 over 7. So 2/7 is the first one. The other one, so my answers are going to be 2/7 and 4/5. Pretty simple stuff. Well, why the heck would you set it equal to 0? The reason that you would set it equal to 0 is based on this idea here. They want to know where the zeros are. So instead of saying y equals, like they do here, and then you get this graph, they just set this ahead, this x set up the quadratic equal to 0, and then they just factor it and solve it. It's sort of like a visual representation would be in the graph, whereas you could get a more of an algebraic solution set answer doing it this way. Sometimes it's nice to be able to graph it. Sometimes you get fractions and it's difficult to tell. So, I mean, if you're going to use a calculator to do it, you'll get weird decimals sometimes that you don't already know. That's why they offer you multiple ways to do it. So from here, let's look at one that's not already factored. Here's one that's not already factored. So I need to factor it. If you haven't seen stuff on factoring before for polynomials, you should go back and watch that stuff. I'm not going to get too deep into it. I am going to say that here's my 15 and here's my 8. I need to think of the factors of 15 that will give me 8. This sign is important. It tells me my answer signs are both going to be the same. If it was minus, they'd be different. I know they're both plus, by the way, because if they're the same, this sign tells you what they are. So it's x plus something and x plus something else. If I do a factor list for 15, I do 1 and 15, and 3 and 5. Well, 1 plus 15 is not 8, but 3 and 5 is. So here and here. Now those are set equal to 0. so I just need to do them individually equal to 0. I mean, at this point, you could probably just say, okay, so the solution is -3 and -5 because it's just opposite signs. But, you know, sometimes it's nice to see both. -3 and -5. That's it. For the next one, a little bit less smooth version of it. So it says 2z squared minus 21z minus 36. You could do this by factoring by grouping or whatever you want. What I'm going to do is slide and divide. So I'm going to move this over here. I have a video on slide and divide if you have never heard of it before. So z squared minus 21z minus 72. And I need to factor 72 to find 21. 72 divided by 1 is, of course, 72. And then you'll go down, and, of course, you know, 8 and 9 are a really nice set that we can... I'll drop my pen there for a second. So 8 and 9 is a definite set, but since it's 21, you're looking for something that's a little bit more obscure, and 3 and 24 certainly fit that bill. 2 and 36 works as well, but in this case, the 3 and 24 would give it to me. This sign actually says that the factors are going to be different, or my answer choices, I'm sorry, the factored form. So one's going to be x plus and one's going to be x minus. The signs of the factored form, that's what I meant to say. I need it to be -21, so the key here is I need to put the 24 behind the minus, because -24 plus 3 gives me -21, so I'm going to put it here. And then 3. Then I need to go back and do my, that was the slide, go back and do the divide part. I'll divide by the 2. That's why I was circling it earlier, to remind myself. This one doesn't reduce, so I'm going to slide it back up here, 2x plus 3. And this one does work, so x minus 12. From here, I can go ahead and just do a little bit of setting them equal to 0. -3 divided by 2. X is equal to -3 over 2. And in the other case, x minus 12 equals 0. X is equal to 12. So my answers are -3/2 and 12. I should put an and here instead of a comma. That's bad math penmanship. So that's the setup. I'm going to show you one more just because it's got a weirdo outlier. Occasionally you'll get one that factors out like this, where you just factor out the common factor. In that case, which is not as rare as you would think, you still set each set equal to 0. It just makes this one very easy. All this means is if I graphed this set, it would cross the y-axis at 0. It also means it would cross somewhere else because there's another component. X is equal to 3/7, so my answer would be 0 and 3/7. So the big deal is all you want to do is set each factor set equal to 0 and solve. If they ask you for a factored form, then you want to give them, I'm trying to grab one, and my hands are slippery today. The factored form is this. If they want solutions, you're going to have to remember that the signs change when you solve them out if they're just simple factors like this, and make your adjustments accordingly. So even though it often seems like you don't need to read to directions in math, in this case it's a really good idea to read them. It's probably a good idea anyway, but I mean, choose your own adventure as far as that's concerned. So I hope this is helpful to you. If you have any questions, just send them in as always.